Hi, I'm Dan Madrikowski. I'm with the UL Firefighter Safety Research Institute, and behind me you see the test fixture that we're building in collaboration with the International Society of Fire Service Instructors, and funded with the AFG grant. ISFSI wants to conduct a program and develop an educational program on understanding and fighting basement fires. So this is our prop, and we've got 2-foot thick concrete walls to simulate an underground basement as appropriate. And then we have a 1,200 square foot house, 3-bedroom house, up mounted on top of it. You see the deck there, and the deck is intended to represent ground level so that we can have firefighter activities up in front of the front door. In cases when we would have small ground level windows, the lower part of the deck here is intended to provide the firefighters a platform to attack the fires there, just as they would if that was ground level. And then we come up again to the rear of the structure, and you see we also have the option for a walkout basement where firefighters would have to fight a fire that might be venting through this opening and impinging on the deck overhead, giving them an additional challenge. As we come into the basement, fairly typical basement, we have thick non-combustible walls to represent concrete walls, and then we have an unfinished floor assembly up above. We're going to do 3 different types of configurations. One of the configurations is that there's no access to the basement whatsoever. There's no windows, there's no doors, so any access to the basement has to come from the top down, either through the floor assembly or down the stairs. So we're going to start a fire down here and get a idea of, with the limited ventilation that the fire has, how big can the fire get, how fast does it get, and what changes will it have as we start to open up the structure. Another configuration or another consideration for types of basement access would be basements that are only accessible through relatively small windows that are up high in the space. Needless to say, if we have a fire in the basement, the hot gas rises. These windows may serve pretty well for a exhaust port, but won't serve very well for an intake port. Can we still achieve flashover conditions with these windows open? Is the fire going to auto-vent these windows? Basically double pane windows and vinyl frames. Or is the fire again going to be contained and shut down? The other scenarios we're going to look at include larger vents, such as an escape window. And over here you see our escape window. And if we start the fire on this side, we'll have a couple of sofas and some pallets, carpeting to represent a fuel load in the basement. And we'll see if that auto vents the window or not. If it doesn't, then we'll break that window, see if the fire responds to it, and then make an attack from that window, or see what it does to the stairs. The stairs, of course, are always a potential option, either as the initial attack or as a follow-up attack. And so we have the stairs instrumented to understand what the gas flows are and understand the velocity and the temperature of the gases going up the stairs. We have oxygen probes installed so that we can determine what the oxygen concentration is, because again, without any oxygen you can't have any heat. So we have them installed at 4 feet and 4 inches above the floor. We have pressure taps as well. We want to understand how the pressure is building in terms of size up. When the fire is growing, usually the pressure is building up, and it'll try to push out any leakage areas. In terms of size up, you would see smoke that would be venting from the structure at that point in time. When it becomes underventilated, we see the pressure drop, and sometimes it cycles up and down. We have protected thermocouples, again giving us a temperature gradient from the ceiling all the way down to the floor, so we can get an understanding of where the heat is at any given time. After our initial ignition in the sofa here, we would anticipate that the fire would quickly move to the fuel load of the engineered lumber that forms the unprotected ceiling assembly. The last scenarios that we'll be getting to, hopefully as far as the free burn conditions in July, will consist of replacing those double steel doors there with glass sliding doors that are 6 feet wide, 80 inches tall. Again, starting the fire, see if the fire auto vents those doors. If not, we'll vent those doors and use those as our point of attack for the walkout basement type scenario. So we have 3 different types of access conditions for the basement. No access at the basement level, high window access, and then the larger ventilations from a walkout basement type scenario. Ideally, you want to fight a fire from its own level. So we're going to be examining a number of different ways of introducing water into the basement, including penetrating nozzles, cellar nozzles, as well as just cutting holes in the floor and introducing a standard smooth bore nozzle or a straight stream nozzle. We are always going to challenge whatever attack method we do. The fires are going to be on one side of the stairwell in the equipment room, and the attack is always going to start from the other side. So basically, we know we can't get water to the seat of the fire, but what benefit is there to cool the gases? What's that buying the fire service? So we can learn from that. We're really looking forward to this project. More fuel loads coming every day. We have a little bit more instrumentation to do, and we hope to start some preliminary testing before the end of the week and be in full test mode next week. Thank you to the ISFSI for working with us and considering to partner with us on this project. We're looking forward to it, as well as helping with the educational component. And again, our thanks to the DHS FEMA AFG grants program for supporting this kind of work to get information to the fire service.